Sir, with your permission, may we start the webinar, sir?
Okay.
A warm welcome to you, sir. It's my privilege to welcome you to the webinar series that has been organized during the National Learning Week. Warm welcome to all our viewers. May I introduce to you Dr. S. Somnath, Chairperson of ISRO. Though Dr. Somnath needs no introduction, I would still like to put in a few words. Sir is a prominent aerospace engineer who holds a bachelor's degree in mechanical engineering from TKM College of Engineering, a master's in aerospace engineering from the Indian Institute of Science, and a PhD in mechanical engineering from IIT Madras. He has previously held key positions in the sector. He was director of the Vikram Sarabhai Space Center and director of the Liquid Propulsion Systems Center. Under his leadership, ISRO successfully achieved the significant milestone, which includes the soft landing of Chandrayaan-3 on the moon, marking a historic achievement in India's space exploration. He was honored with the prestigious Karnataka Rajyotsava Award. He has also received the Performance Excellence Award from ISRO for his role in the realization of GSLV Mk3. He was felicitated with the esteemed KPP Nambiar Award, reflecting his invaluable contributions in the field of space technology and research. Today, he would be addressing us on the topic Aiming for the Stars, India's Journey in Space. Over to you, sir. We are eagerly waiting to undertake this journey with you.
Thank you so much. I hope I am audible now to all others. Thought that I will show us a small presentation as well, a PowerPoint presentation which could be viewed and seen. I hope that you are able to see the Vikram lander and the Pragyan rover coming out as an animation. I hope that you are able to see that. This talk I thought that I will cover in the next 35 minutes or so about the journey that we have undertaken in terms of creating the space assets that we have today, the vision that has been unveiled by our Honorable Prime Minister in the recent times on how we are going to take the space journey forward in the next 25 years in the Amrit Kal, what are the ingredients of it, and how the technological growth in this sector is happening in vis-a-vis our work in ISRO and the space sector, and how our application domain, which is the core of what we are doing in ground, on Earth, how it is going to impact. But there are a huge amount of data that need to be shown, but I won't spend time on all of that. A little glimpse of what is going to be shown. So this is what I thought that I will cover now. We look at the historical perspective of India working in space. Just in one slide, I want to tell you that this journey we started way back in 1963. Why I put these photos are their classical photos. No, it shows the journey was very frugal, very low cost. We continue to love these photos so much about the early work of people like Kalam is there in the picture. Aromadan is there in the picture. The bicycle is still an actor also along with the rockets and the people where it was the first carried on board, the rocket parts. The Tumba, where the journey started, but now it is spread all over India, both in ISRO as well as in other organizations. Next slide. See, today I quickly jump from 1960 to today to look at how the assets are created in space in terms of the satellites, the various types of satellites, and also the domains which we address and cover. It's something very phenomenal. In terms of the communication satellites, we have 18 of them working in various areas like the television broadcasting, the VSAT connectivity, the internet services, and other services for special users. The Earth observation satellites, there are 22 in various domains like the spectral periodicity, the resolution, they differ. They are optical as well as radar, as well as other forms of observations. We have climate and weather satellites also, which are looking at Earth in various bands. We have the NAVIC series of IRNS satellites and also the science missions, which are the one which I have listed there. So we look at various operational assets and continue to run them to support various domains, including telecommunication, resource mapping, meteorology, the oceanography, fisheries, Gagan services, which are for flights, the NAVIC support, the disaster management, search and rescue. So if you look at the users, capacity building, institutionalization, externalization, all are part of this in the infrastructure. It's just not satellites and rockets. The downline work also we did in terms of creating the connectivity, the softwares, the programs in terms of the interface with the ministries and departments. Next one, please.
Slides are not moving, sir. Slides are not moving.
So I believe the slides, there is some problem of movement. We can just go back and remove that and put it once again in the slide. Show us, yeah, just put it. You put it as full entire screen you select. Yeah. Yeah, then select the whole thing. No, select the entire screen. Yeah, then select it. Then share. Yeah. Now put it full. I believe this screen will be visible now. If you look at in terms of the statistics, in number of the missions that we undertaken, and also the launches, the missions in terms of the number of satellites as well as rocket launches, the student satellites. But the most important striking part is the satellites that we have launched from 34 countries, 431 satellites, small, big, dedicated missions, all inclusive. And also we did a lot of technology missions like the missions related to crew modules, the missions related to reusability, the mission related to the air breathing. All of these were the essential technology demonstration along with this, the regular missions. If you look at the assets that we have created in terms of the technological capability over a period of time and also the rockets, I think I would like to talk about these 4 rockets now. These 4 are currently operational, the PSLV, the GSLV, the LVM-3 and the SSLV. PSLV has now already logged 50 plus missions, successful missions. Till now we had 2 failures, the inaugural mission and the one of the intermediate 37th or so that we had a problem. GSLV has come of age and is doing regular missions now, but it's going to retire soon after some missions are completed. LVM-3 is a bigger rocket which is going to evolve and become the human spaceflight mission. SSLV is the one which is doing the small satellite launch vehicle missions with very low cost of access. In being, while building it, we have been developing capability. I think the journey in the beginning was not that easy. The journey during SLV3 time, ASLV time, I don't want to dwell on, where we faced a lot of failures. It is primarily because of the knowledge, the 4 rocketry and satellite building were gained over long periods of time because it was not easily accessible to us. So in many capabilities in aerodynamics, propulsion and all this which I have listed there came through hard work and dedication of thousands of people who are still with us and who left us already. But then this knowledge is still resident within the organization to create future space assets. Next. And one of the important things which I can tell you is about the mission that all of us have been very happy about is the Chandrayaan-3. That it made the soft landing at the south pole of moon. And this really changed the way all of you looking at the space. That's why we are talking about going to stars, etc. today. That we were able to accomplish this mission through 3 important Chandrayaan missions, the Chandrayaan-1, Chandrayaan-2 and 3, which I will talk a little later. But this is really remarkable, our ability to go and touch on the surface of the moon, especially at the near the South Pole, India being the first country ever to do that. And not only that it made the touchdown, but it also did scientific experiments. All the 5 experiments on board in both the Vikram and the Pragyan were very successful, and we have huge amount of data. And we'll just discuss it quickly on the outcome part a little later. Next. The journey of the Chandrayaan-3, where I have been the fortune to be there with ISRO while we look at all of this, the building of the rocket as well as the satellite has been a great journey. My team in ISRO has been splendid in building both the rockets and satellite to its perfection, that we had no anomaly this time. Learned from the failure last time. But then the launch journey to the injection to the orbit of moon, capturing the moon orbit, bringing down to a low altitude, and then finally making the soft landing on 23rd August. Everything went with perfection. We had no anomaly to talk about. So it is a very coordinated and hard, difficult effort because it's happened because of the learning that we had in the previous mission. Also the interface that we had with a lot of other space agencies. So we should thank many other agencies who helped us in providing the global tracking of this, as well as providing support to us to make this mission successful. So we should not just claim that it is all our work, but then it is a cooperation that helped us to do that. Next. The Aditya L1 that followed that mission was really one of the important missions, the first space-based Indian mission to study the sun, where we looked at a satellite which will go and observe the sun for 24/7 basis with no obstruction from any celestial bodies. Now, not from Earth or Moon. So it is put at a place called Lagrangian point L1, where we can look at the sun in a continuous manner. So it's a fictitious point in space, rather a point which is defined by the geometry or the gravity fields, that this will rotate in very huge orbit around that point, and it will always look at the sun and also provide direct communication to Earth in a manner that we can get the data on a continuous basis. So this gives you information about the solar activity. I think all of you are aware about the solar eruptions and corresponding issues of the coronal mass ejection and it causes in the space weather and how it impacts various ionospheric activities on Earth. So we put instruments on board this mission, which are listed here, but I don't want to go into each of those missions, which includes the observing the coronagraph and looking at the ultraviolet rays, looking at energies, X-rays in low energy as well as high energy, looking at the particle emissions as well as the magnetic effect on the path. So all of these are consistent observations, which is one of the very interesting payload suite that we have on board L1, Aditya L1, which is producing very interesting results. Next. So all three missions, recently the Chandrayaan-3, the Aditya L1, and also the one which followed that, the XPOSat mission, which is X-ray polarimeter satellite, look at the black hole studies, have really raised the imagination of all of you in terms of looking at the scientific goals of our missions. Next. So to talk about Chandrayaan, I think it's very important to talk about the Chandrayaan-1 and Chandrayaan-2. Chandrayaan-2 had very interesting camera, the OHRC. Orbital high resolution camera on board Chandrayaan-2 is one of the best in the class, 25 centimeter resolution. You can imagine the entire moon has been mapped using the high resolution camera. Today, this imagery camera is so much in demand. And I can tell you the other agencies who are doing moon missions are all asking us to provide images of the moon where they are actually likely to land. That site images are being provided by India today. I think this is something that you should all be proud of. So our images are used by the Japan recently. The other nations are also using it. I think it's a great pride for us that it is continue to work and provide this information. And we are able to do that in a very successfully. Next. And another important finding is the Chandrayaan-1 finding, which is the identification of water on the moon. Today, we know that there is water on the moon in various forms. And the only thing we need to discover is that whether water is available in the form of liquid or solid form. But then we know the hydroxyl molecules are there, and this discovery happened out of two payloads. The first one being the M-Cube, a mineralogical mapper from the US. So on board Chandrayaan-1, we had many other nations' payloads hosted, and this was the wonderful finding, which is again further corroborated by the later findings in Chandrayaan-2 and 3. So next one. Similarly, if you look at the outcome from missions like Chandrayaan-3 and Aditya L1, I just gave some of this important information which has been recently published in journals. For example, the Chandrayaan-3 looked at the elements around the Shiva Shakti point and also looked at other mineral composition and also looked at the termites on the lunar south pole. This data has recently come out, and there was some good finding on the location where the Chandrayaan landed, that it has been a place where it was a impact point, it is a fresh point, and we don't see much of debris or troubles around, indicating certain characteristic of this location has been recently published. Similarly, the Aditya L1 also look at the type of solar disk images in the ultraviolet regime in 11 bands. Similarly, the identification of X-class solar flares, which happened during May 2024, solar storm has been detected by the Aditya L1. And it will continue to work for next 5 years or so. Aditya L1 will continue to provide so much of scientific information on sun in the coming days. Now, going further, next slide. Now, look at one of the important missions that we should not forget while we talk about Chandrayaan-3, Aditya L1 is one of the very interesting mission, the Mars orbiter mission, which happens few years back. But this is very important in our journey. Why I tell this is Mars orbiter mission, it not only produced beautiful images like this of Mars, you can look at it, see how the three-dimensional map of Mars has been generated by our orbiter for the very first time. It is a beautiful image. Today we have the entire 3D map of the Mars. But the most important part of the Mars orbiter mission is the autonomy of a satellite. It went to Mars and it did that Mars capture, and because the communication has been a serious problem over long distances. So we created the Mars orbiter mission with so much of autonomy. The software capability that has built into the sensor capability that has built into the Mars orbiter mission translated into the future satellites. So Mars orbiter mission paved the way for so much of building of more computational and autonomous capabilities on board satellites in later times. I think that is a credit that we should be giving to Mars orbiter mission in addition to the scientific gains that we got. Yes. AstroSat is another interesting satellite that we launched, and many people actually don't know about it. I think this is very sad part of it. I think I would like to tell you people that you must read about it and then understand how AstroSat science outcome has been one of the phenomenal scientific satellite that we ever launched. And it is continuing to work beyond its original life, 5 years. It's going in further. And this is one of the best observatory on multispectral capability on board in a very compact first astronomy satellite that we have ever launched. In ultraviolet, it is looking at in X-rays, etc., etc. So many other findings and publications has come out of it, which is really fantastic if you look at the type of investment that we have made in creating such a satellite. So I believe that in the future we will be launching further astronomy missions like possibly the Chandra, the various other grades, the Kepler and many other satellites that the Westerners have launched. I think we will bring one day that class of high level of observations to look at the universal phenomena like the creation of the universe, etc. possibly one time. Next. Let me spend a little bit of time on the Gaganyaan program. The Human in Space is one of the ambitious programs that we have taken up to launch using our service module, crew module on board our human-rated launch vehicle. And this program is currently running, and I'll give you a little more information and its expansion plan. But meantime, I also tell about you the test vehicle, which is a small cost, low cost vehicle we have developed to test the crew module. This was launched some time back, where we aborted the mission intentionally to demonstrate that in case it end up in some anomaly, we should be in a position to save the crew. How the crew module comes back in terms of anomaly has been well proven, and we have recovered the crew module also. And the next test vehicle mission is scheduled coming years. But meantime, we are getting ready for the human-rated LVM-3 mission with the uncrewed crew module and service module. We will be getting ready for launch. And the vehicle building has already begun. And this is a great news. And so all the parts are moving to Sriharikota, and we are getting ready to start the campaign coming month itself, so as to target by this year or early year launch of the first ever human space flight uncrewed mission. Now, after this progress has been made, I think this is a very important part of my talk to talk about the Indian Space Vision 2047, which has been announced by Honorable Prime Minister. So in the backdrop of the landing of Chandrayaan-3 on the moon, what we are looking at further is how the Gaganyaan program is going to evolve. A future rocket called NGL will develop, how a Bharatiya Antariksha Station will be built, and we will go to moon again, ultimately resulting in landing of an Indian on the moon by 2040. So this is a broad vision that has been now well laid out. And we are working on the packages that will lead to making this vision a reality. Next. Looking at the moon mission, it's very important that we need to have a continuity of Chandrayaan program. 1, 2, and 3 missions have really taken us to some place. It is now successful landing on the moon has happened. Now we are looking at how to come back from moon. So we are looking at a Chandrayaan 4 series where the lander, ascender, descender, transfer module, etc. are incorporated in a complex mission configuration where it will go and land on the moon, take off from the moon after collecting samples and come back and send that sample back to Earth so we can look at it later. It's not the sample that is important, but our entire algorithm of going there, landing there, coming back is the complex part which we would like to demonstrate using Chandrayaan 4. And later we would like to look at a Chandrayaan 5, which is a joint mission with Japan, where we are looking at how to land a bigger rover. You know, Chandrayaan 3 had a rover, which was just a very small, cute little rover, 35 kilogram, 27 kilogram or so. But we would like to send another 350 kilogram rover up in the Chandrayaan using Chandrayaan 5 series of mission. But when you go to moon, bring back sample, there are a lot of technologies. how to launch it. Today, our rocket capability is not enough to launch a satellite to go to moon and to come back. So we need to plan either 2 missions. And next. So what we have worked out is a complex configuration of Chandrayaan-4, where we want to do with many studies were done. What way we can do, whether with the 1 LVM3, 2 LVM3, or with the PSLV. And finally, we have concluded that we are going to do with 2 LVM3 with the 2 complex configuration of modules. As we are shown here, I am not going into every detail of it. So both of them will be similar in mass with a lot of fuel inside, and it will be launched in 2 rockets near time frame, and they will dock in space and go to moon, land one module on the moon and come back, and finally land the little fellow that is seen on as a crew module in one tip of the other. So that will bring back the sample back from moon. But then there is a lot of robotic activity involved. We need to have robotic arms, drilling systems, augers, collecting samples, packaging them, transferring them. I think all of these are part of the technology development program, which need to be done in next 1 or 2 years of time. Meantime, we work on the LUPEX program. You can just compare the Chandrayaan-3 to the LUPEX or Chandrayaan-5 mission. It's going to be a huge vehicle which will launch the a rover which is weighing 350 kilograms. So this is also a precursor for preparing us for future moon missions. Next. We are also working on a Venus mission. I think you know the Venus is a nearby planet that is nearer than Mars. But the issue with Venus is that going there and observing the Venus is very complex because it has a very thick atmosphere and almost 100 bar in pressure, and you cannot penetrate it and see it much better. So many people have gone there earlier, and there is an interest coming up to launch more missions to Venus in the year 2028. So we are also working on a mission to Venus. It's also part of our scientific pursuit that we have done in the recent times. Next. Now, to do all of this, we need a lot of enablers, like the docking capability, which is going to be demonstrated immediately in a mission called SpaceX. So this year, we are getting ready for the launch. The satellites, 2 satellites, which will go to orbit and get docked like this in an autonomous manner. And we are also working on various other robotic capability like tethered capturing, satellite refueling, rendezvous with the payloads, etc. And also looking at ideas like servicer missions where we can go and fill a satellite in orbit using fuel. Like a car is taken to a petrol bunk and then you fill up the fuel. We can send a filling cart and then fill up different satellites and make it live again. So these type of concepts are being worked out today, which will enable future exploration. Next. We are also working on satellites like a G20 satellite, which is going to be an environment and climate satellite, where we work with other nations to put payloads on board. So this is another interesting satellite that are currently being done by ISRO. Okay, let me talk about a little bit on reusability. I think these recent achievements in this year is one of the very well-known achievement is the landing of the reusable craft, the RLV Lex. Possibly you can see the videos in our website. And both this has proven that it is possible to work with a winged craft to come from orbit. So I am not going into the future plan. I am just showing you these 2 pictures to show that this has been a very wonderful journey. Last many years, we have been working on it and we have been successfully accomplished autonomous landing of this reusable rocket. And this is scaled up to become an orbital plane soon, and where we will be able to put payloads and spacecraft into orbit. But it's going to be unmanned. We are not planning to put human beings to go to space using this. Next. Meantime, we are also developing bigger rockets. The PSLV, GSLV, LVM3, SSLV apart, we need to go to the next generation of launch vehicle, where the payload capability will be tripled and the cost will not be tripled. That means we will end up with a low-cost rocket, which will give a higher payload. So this is a goal, and currently the program is on to develop reusable, semi-reusable heavy lift rockets that need to come up in next 5 to 6 years of time frame. Next. Meantime, I talked about the SpaceX. We are also working on satellites like technology development satellites. One, where the all-electric propulsion will become one of the important demonstration to showcase that it is possible for us to bring down the size of the rocket, satellites much lesser, and put in new technologies of orbit rising. So this is primarily used for communication satellite, but electric propulsion can be used for future microsatellites as well. So that's another domain where we are working. And 2 of the important technology development we are working on are called the quantum satellite. It's called secured application for quantum key distribution using optical communication. So this is called SAQTI satellite. For that, we are currently we got approval to work on it, where we need to have an optical communication from satellite to ground, so that we can create the quantum key distribution network, which will be used applied on a terrestrial communication link. Similarly, another satellite called TDS-02, where we would like to demonstrate a software-defined radio-based satellite, where the frequency selection, the signal, your beam formation, etc., can be changed based on software protocols. That means that you are in a position to reconfigure the satellite based on the demand profile in ground as well as with the time how it is going to change. So this is another important technology that we would like to demonstrate. Next. Now let me spend a little bit of time on applications, which is very important. I talked about a lot of technologies, but equally important is to look at how some of the examples I would like to tell you that what after doing all this communication satellite, remote sensing satellite, the navigation satellites, etc., ultimately it become beneficial to community. One such important tool that we have demonstrated is the Krishi DSS, Decision Support System, which is working with using the geospatial data, mapping the various entities like the crops, the soil, the flood impact on the crop, drought impact on the crop, yield estimation are brought into a platform where the various stakeholders like the government entities in technology, in the agri-tech industries, research areas can actually access and use it. So this comes out of the remote sensing data. So this is one of the examples of the use of space-based remote sensing data-based assessment. Next. Similarly, another important domain that we are working is in terms of the disaster warning and other observations which are important. So, satellites are one of the important tools for observing the changes that are happening, and from a larger scale that you can see it. Possibly, if you go into our website today, the ISRO's website, you can see the new cyclone that has happened and the type of information that we have provided. Of course, it has had I think it is moving away and it is getting over because it has land impact has already happened. But then, today the cyclone prediction, cyclone path tracking, etc. happens using these satellites. And similarly, we have ocean satellite, OceanSat-3, which is one of the best of the class, which gives you so much of information related to the ocean and related information. The microwave humidity sounder is one of the important payload on board this. The block shows the wind vectors coming out of the scatterometers. So all this data goes into various models for prediction of the weather and climate. And not only that, it is linked to the disaster management information system that ISRO has developed and deployed in the government for us for providing consolidated information of various disasters happening all across the country. Next. See, one example is a forest fire. See, forest fire happen across large locations across the country, and hundreds of them happen. And many of them are not detected, some are small, there are some false alarms, but then near real-time forest fire detection and dissemination is very important, and we work with the Forest Survey of India and various other users, and this information is provided to the users so they can act on it. And there are various other tools in terms of burn area assessment and over risk index management, etc., and then make a little bit of prediction, not exactly everywhere. So this is very important application that has come out of the observation of thermal imaging that is possible from space. And possibly with the future satellites, I think this capability is going to increase. Future we are going to have Trishna and other satellites, possibly this capability with the more thermal imaging satellites coming up, possibly it will become better. Next. Now, let me talk about one of the recent landslide disasters. So using satellite is possible to observe them, but unfortunately the issue with them is that we cannot give a real-time information about what is happening because the satellites need to be there at the right time. But then with the observation capability of various parameters, we have created landslide inventory where there are possibilities of landslides, and atlases have been made and issued and various stakeholders and government decisions, and susceptibility mapping has been done for certain states. And early warning has been established in some places, but it needs to expand. But post-landslide assessment, damage assessment, its scale, etc., quantifying are really important tool for decision makers to look at rescue or reconstruction actions. I think this is very, very important how space helps in one of such disaster situations. Similarly, another domain is the National Information System for Climate and Environmental Studies. I'm not going into every detail, but then look at the varieties of domains that we are addressing. Climate and weather is very multi-institutional activity in India. There are various stakeholders working and essential climate variables. There are 50 plus of them, and space is one area through which that we can observe maybe less than 50% of them. And but today we have an ability to observe at least 12 of them. And this is through various sensors available on board satellites. And also there are terrestrial sensors which looks at the land, ocean and atmosphere and provide this information for various users. And the products are also generated, and this data goes into various downloads. It goes into modeling. It goes into database generation and scientific studies. So this is very important. Climate-related studies that are where space becomes an integral part of it. And you can look at this website, nices.nrc.gov.in, to see how this data is coming and used across the country. And of course, this data is used world over as well. Next. We disseminate this data through a platform called Bhuvan. I think many of you who are not familiar with this, who are listening to this talk, please look at Bhuvan. And you can just type in and then get this Bhuvan and go and see. This is very important for us to understand how Bhuvan, which is a specific geoportal made for India based on satellite data from Indian satellite as well as from that satellite data that we are procuring from others, to create various thematic layers. And we have created it for various government applications and also the flagship programs, and also specific to states as well as ministries. So it's very rich in terms of its information, but it's not, all of them are not available to general informers. If you register and then becomes a registered user, many of you can access this and use it for study. It can be used for research. It can be used for decision making. And we have also provided tools how decision making can actually happen, making use of the Bhuvan support platform. And it is also a huge inventory of information related to the assets that we have created, the assets that we have which are natural and also created using our investments. And it also helps in terms of long-term planning and monitoring. So this also complies with the geospatial policy. And we also have different portals today to get you the data. I think all of you are aware of the recent geospatial policy also, where the geospatial data that we have created out of the public funding, data is actually available to you, made free. And you can contact NRC to find out how you can access this data and make value out of it. It's very important. So I advise you to look into the Bhuvan portal and then learn a little bit about it and how that is becoming useful for the entire system. Next. So I would like to close here saying that we have been working very hard to create a lot of capability in space sector, not only building rockets, launching satellites, but also doing inspirational missions like the space research and science missions. We are looking at operational missions to support various support services like the communication, remote sensing, navigation, and strategic activities, creating applications from this data that is coming from satellites for day-to-day use into your life, inspiring you people, young minds, and also synergizing with the rest of the natural resources, creating capacity in this sector with all the stakeholders, especially with the emerging space actors in the private as well. So thank you so much for this opportunity to listen to my talk. We are all with a lot of expectations looking at the space sector for its future growth to make you all part of this journey. Thank you.
That was really wonderful, sir. May I take some time, and I've got a list of questions that the viewers are wanting to ask you. Maybe I'll just club a few of them and put you two questions perhaps. Let me start with the first one. The common man always thinks that the future is in space and we're going to get all our solutions and answers to all our pressing challenges from space. You have already touched upon the various applications of space technology, be it agriculture or disaster, weather forecasting, etc. Are there any possibilities for some answers from space for industry, medicine, etc.?
Let me tell you, there are many things. For example, you are aware of the Industry 4.0. which is one of the emerging nature of the industry, is an interconnected industry, where the IoT interconnected systems becomes integral part of the industrial revolution in the coming days. Supply chain management, logistics becomes important. So we see for example, drones, robots become an integral part of it. The communication across them through various communication channels. Space becomes an integral provider of this industry of 4.0 revolution, I believe. So the space-based internet connectivity, IoT services become the integral part of it. Similarly, drone, when they become huge in numbers, the control of drones, the traffic management of drone, etc., there is a possibility to handle through space systems. So you talked about the other domain of medicine. Now, I look at medicine and space connectivity through microgravity. For example, we are talking about building space station and sending humans to space. Why we are sending it to do certain scientific research in the vantage point of doing in space, where we have a microgravity environment where molecular synthesis will be very good. We can work on materials much better. And also medicine synthesis, bio activities up in space are really important, especially in domains where the radiation is there. There are some sort of mutations, which is again useful to be used for controlled experiments. And just now I'm back from Department of Biotechnology, where we have signed an MOU with them to work on similar topics, how space and biotechnology can work together in creating new avenues in those domains. So they are related to medicine. Of course, bio is a larger segment of the medical part of it.
Right, sir. I mean, from your answer, I kind of bring the next question to you. The biggest challenge in government these days is that various organizations work in silos. So you already said you're working with biotechnology. How else is ISRO breaking these silos and working with other departments and ensuring that we are not reinventing the wheel?
This has been the way we have been working with other departments. It is a very important mandate to us. In 2015, our Prime Minister himself came to an important program of space connected with other ministries. So all ministries and departments were called there to look at how space can become useful for governmental work, especially. And out of that, many projects came up. We started working with all of them. But then, of course, some of them have really fruitioned into successful results, some not. For example, I'll talk about the work which we do with the Survey of India. So the entire survey records, we work through the database that we created at various resolutions, and we have programs to update it with a higher resolution. We work with the Water Resources Ministry in terms of creating water database, both in surface and underground water and others. We work with forest departments that we've just seen. We work with railways in various ways in looking at how unmanned river crossing accidents can be handled through various space-based solutions. Of course, communication, we are integral part of the communication network infrastructure, the backbone through the mobile connectivity and other services. Then, of course, we work with the Ocean Department, the Ministry of Earth Sciences, to create the tools that are required to observe ocean and support various services like the observation of the coast, looking at sea state estimates, sea color estimates, fish catch estimates, and many other related activities. We work with IMD in terms of providing whatever I mentioned about the data that are required for weather forecasting. So I can go on telling, we work with the ministries of Home Affairs to survey the islands. We have thousands of islands, how to map them and classify them. We work with the Department of, for example, the heritage sites that we are mapping. Look at which are the heritage sites and how they are captured, how uncontrolled construction happen, how to regulate them. So through space-based data that we provide infrastructure support in terms of new lines laying, like railway lines, electric lines, etc. How that can be well laid based on this data. Our data is very important for all the armed forces to keep vigil on the our borders. There are many things like that. I think if you start listing, some I don't remember also. there are too many.
Very true, sir. I can totally relate to it because I recently had the opportunity to visit INCOIS in Hyderabad, and you also talked about the fish catch, etc. One last question, though I promised you that I'll be asking you too, but this is one question from my side. There is this high risk that any mission can fail. So how do you as a leader cope up with the anxiety, keep your team motivated? And if at all any mission goes on and doesn't become successful, how does the team cope up, and what role can a leader play in that?
See, we must understand the space in all mission, failure is a possibility. So we don't think that success is always a possibility, but then what we do is the probability of failure is minimized by certain actions. That's what we do. So it is done through appropriate design, appropriate interventions, reviews, and also to ensure that the technology level of knowledge at the various levels are of high order, so that we have not made unintentional or non-intentional mistakes in the whole process. So we minimize the possibility of a failure. But failure is always looming on top of us when we do missions of this nature, whether it is a launcher mission or a satellite mission or a space-based activity. Failure is a possibility. This is because of the complex nature of the problem and thin margins on which that we work. So unlike a bridge which is built with a margin of 5, rockets are only built with the margin of 0.1. So, and similarly, satellites are built with hardly 0.2 margin. In terms of, I'm talking about, you can understand, factor of 5 versus its 200th size. So this type of scale of low margins make it vulnerable for failures. And this depends on your extent of understanding and knowledge about the system. This is very important. So keeping the knowledge level very high, keeping the processes very rugged and transparent and involving everybody is one way of ensuring success. And we have been trained to handle failures. I think through the failures, we have learned a lot of things. Chandrayaan 2 failed to make the touchdown. From that, we learned to make Chandrayaan 3 succeed. And we will not repeat it. Of course, new problems will always arise. We are prepared for it. And that is the state of mind and nature of this work.
Thanks a lot, sir. That was really very well put. Now, I think I would like to take this opportunity to thank you for taking us through India's space journey. It was really a wonderful journey, and we felt we are part of it when we were listening to you. You kind of broke down the various missions for the unlettered people, common people like us who are not as such having a technology background, be it the moon mission, Mars or Venus. Your collaboration, which ISRO is planning with other countries, having with other countries a brief of the launch vehicles. And you had also touched upon the Vision 2047, towards which the entire country is moving and the government is geared up for it, and also touched upon the various applications of space technology, be it agriculture or disaster. So again, a lot of gratitude from my side. It was really great listening to you, sir. Many, many thank you to you. Thanks a lot for joining.
Thank you so much. I think it has been a great journey for us. I think the support that the government provides, our Prime Minister himself is being the Minister of Department of Space. I think his mentorship and support is really phenomenal. I think all of you must know about it. He has keen interest in our work and in our progress. I think that's why he has announced our opening of the space sector in 2020. We have private companies coming into space sector in large numbers from 2014. If you compare, we have more than 250 private startup companies with young people with starry eyes working on rockets and satellites and capabilities. So it's a very exciting time for all of us. Not only that work that we do in ISRO, we do mentor new players to come into the sector to create a vibrant space economy in India. So that's why we have new actors like IN-SPACe working to handhold and regulate these areas. In NSIL, the New Space India Limited, the PSU, working to bring in more business and activity in this domain. Those are another important tasks that we are working on. I think we must thank the support that is being given and also the great vision that has been shared by our Honorable Prime Minister.
Well summed up, sir. Thank you so much for joining us. Thank you. Thanks a lot.
Thank you.